Hey Techno Studs, this video is all about the routing table. We've seen the routing table a few times already, so we should at least be familiar with how the routing table is formatted. However, there is some additional information that we should cover about the routing table, such as how does it choose which routes actually get onto the routing table? And if there's multiple routes to the same destination, how does the router choose the best route? Well, let's get into that information. We're going to start out by talking about route installations, how your router chooses the right routes to put into the routing table. It could have a lot of different options to get to the same network. So which one does it choose to go into the routing table? And one of the answers to that is administrative distance. So we'll get a little more in depth into administrative distance as well. Then we'll get into choosing the right route. So once things are installed onto the routing table, there still could be multiple options to the same networks out there. And so how does it choose the right option? So we'll get into choosing the right route, and then we'll get into what happens if there's no matching route in the routing table. All right, here's the scenario that we're working with. We have a PC right here with this IP address that's trying to get a web page from this IP address right here. It sends out an initial request and it reaches this router right here. And this router has certain information in it, but how does it get that information? Well, let's say we have a couple routing protocols that are working. We have RIP and OSPF. And so it is learning of these routes through RIP and OSPF. Now, this router right here reports in with both RIP and OSPF that it has access to the network. So therefore we have a route for each one of these destined for this network over here that this server is hanging off of. It also gets similar information from this router down here, one from RIP and one from OSPF. So it has to make a determination of which route it's going to choose. Furthermore, we may have a static route that's also entered on here. And let's say the static route points in this direction right here to get to this destination. So what we need to do is we need to start rendering down what out of all of this information, we have now 5 routes to get to this final destination. How is this router going to choose, first of all, what gets installed onto the routing table? And then second of all, what route it's going to choose if there's multiple routes that are entered onto the routing table. Well, the first answer to this is administrative distance. Administrative distance is a way to tell this router which one of these protocols is more favorable, which one's going to give a more honest answer to how to get to this network right here. So for instance, a static route has administrative distance as 1, and lower is better. So an administrative distance of 1 says that if I've assigned a static route on here, I probably want that static route to be used. And if I didn't want that static route to be used, like maybe it's a floating route that I want to only use as a backup scenario, I would change the administrative distance to be something much greater than 1, something that's greater than RIP or OSPF. So administrative distance is a way to gauge how it learned, through what protocol it learned of the direction to this server right here, and how reliable that is. The second thing is going to be the metric. So what is the metric? So even though it's learned, okay, maybe OSPF is the preferred method here, but it's learning OSPF through this router right here and OSPF through this router right here. So it's learned it, and it's going to have the same administrative distance because it's both learning that through OSPF. So that's where the metric comes in. There's going to be a measurement in OSPF. It's a measurement of cost, of how much cost it takes to get in this direction or how much cost it will be to get to go from this direction. So let's take a little bit further look into that. So if it's a directly connected network, it's going to have an administrative distance of 0. It doesn't need to go through any other routers or any other devices because it's directly attached. And that's going to be the fastest way to get into that network since it's directly attached. So that makes sense. The next one is static route. We can actually, with a static route, also set the administrative distance. So we can specify what the priority of the static route is going to be. If we don't specify it and we just leave it at its default, the default is 1. We also have an EIGRP summary route, which is going to be at a 5. We've got an external BGP, which is a 20. We got an internal EIGRP, which is 90. So notice that we have EIGRP here, we have it as a summary route, and we have it as an external route. And they're all different administrative distances. And that's because it can learn about EIGRP in a few different ways. And so depending on how it learned it, it may favor it or not. OSPF is 110, ISIS is 115, RIP is 120, and internal BGP is 200. So we see a range from 0 to 200. Remember, the lower number is more favorable. So as we work up in this graph, this is more favorable towards the top. This is what we love is up here, and it doesn't favor the ones towards the bottom of this graph. Here's the output of a show IP route. So this is the routing table. We're looking at the routing table. And as we've seen in prior videos, the O stands for OSPF. And when we take a look at the administrative distance, we see 110 on that. So 110 is the administrative distance. We also see that there are several directly connected networks with the C here, and it doesn't specify anything about the administrative distance because the administrative distance is 0 on those. We also see static routes here, and they are set to the default of 1 right there. This router also could be getting the same routes through RIP, but RIP has a higher administrative distance. RIP is 120. So it wouldn't ever see the routing table. It'd never get installed on the routing table because OSPF is the preferred routing protocol. It's going to choose the lower administrative distance routing protocol, and that's OSPF. So the other thing that affects what routes actually get installed on this routing table is this metric right here. So this is showing the metric. And specifically with OSPF, OSPF has a metric of cost. What is the cost to get to that network? And so we see 132, 67, 66, 2, 131. So we see a different cost to get to these different networks. So with that as well, with OSPF, we're not going to see different costs actually being installed on the routing table. They're going to get weeded out if it's a higher cost to get to that. I believe one of the exceptions to that would be EIGRP because it can do unequal cost load balancing, but we're not going to get into that too much. Just know that it's using administrative distance and metric to determine what goes into the routing table. And if there are duplicate networks that it can get to, there's duplicates within here, then it's going to choose the one that has the lowest administrative distance and the one that has the lowest metric. Each of your dynamic routing protocols is going to use a different metric to measure what is the best route to your final destination. If this router is trying to get to this network right here, what it needs to do is determine what is the best route. OSPF uses a metric of cost versus RIP uses a metric of hop count. So let's take a look at hop count here. Hop count would be to get to this network right here. If it were to go this direction, it would be 1, 2, and then it would get into that network. In this direction, it would be 1, 2 to get into this network. So it's treating both of these routes as being the same to get to this final destination. OSPF works a little differently though. It's based off of cost. It looks at bandwidth. So let's say it's a 100 meg connection, both on these sides, and it's a 1000 meg or 1 gig connection on these sides. This would be the better route to go. Well, RIP would report that it's the same no matter which way you go. It will be the same hop count. Therefore, it's not the best at determining what is the best route. OSPF is actually more accurate because what it does is it accounts into the equation. It accounts the cost or the bandwidth of each of these links. And it sees that this is a slower connection, so the cost is higher for those links. The bandwidth here is higher, so the cost is lower. So then what gets reported into this router right here is the cost or metric to go this direction is actually cheaper than the cost to go this direction. So this is going to be the route that gets installed onto the routing table. So far we've talked about administrative distance and metric as a way to determine the best path to get installed on the routing table. And the routes that don't measure up, the routes that are not the best, are not going to get installed on the routing table. Now, when an IP packet comes into your router, and the router takes a look at the destination IP address, it could actually still match multiple network statements in here. So it still needs a way to determine which route I'm going to use. So that's where longest match comes in. It will take a look at what is the longest match for within the routing table, so I can send it in that direction. So let's take a look at longest match. Let's say an IP packet comes into a router and it's destined for 10.1.10.34. I've also got the binary equivalent of that. In its routing table, it has multiple network statements. So here are some of the network statements that exist on there. All right, so what I've done is I've created a binary equivalent to all of that. And this quad 0/0, this /0 says that nothing really needs to line up. So all the red means that nothing really needs to line up to match this statement, to match this route. And so if we look at this, well, of course, all of these are, none of it needs to match, so we're good to go. But do we really want to send it on its default route? Well, probably not. So this one right here matches up with this right here. So this would actually be a better route to go because we've got more matching bits. Remember, these don't matter, so this would be a better route than the default route would be. And we can see that this one actually has more matching bits to it, so that would be even better. And you can see where I'm going with this. Even up to this point right here, this has all matching bits for the /27 that's in here. And so even this one would line up and be a good match for this. But the best one is the longest match, what has the most number of bits matching. And so we see this one right here, but this /32 means that they all need to match, and we see that this last bit doesn't line up. And so since that doesn't line up, we can't use that one. So the longest match out of all of these would be this route right here. This is the one that we would choose. That's where the default route comes into play. Notice I switched this first bit right here. So I just added a 1 to it. Therefore, it doesn't line up with any of these now, and except for this default route. And so that's the one it's going to choose with a default route. So what happens if there's no match in here? Notice I changed the first bit. I just added 1 to it. I've also had to take out the default route because if we had the default route, it would still line up with that. So I took out the default route and now we don't have any matches. It doesn't match up with any one of these. So it can't use any of these routes. Well, when it doesn't have a route that it can match up against, then it just drops this packet. It doesn't do anything with that packet. So that's what happens if there is no match in the routing table. We started out by talking about route installation, which routes actually get put on or installed into the routing table. Your router uses administrative distance and metric. Administrative distance is a way to determine which is the best protocols to use, which is the most reliable protocols to use, and then out of those protocols, what is going to be the best route to take. And then once it puts that into the routing table, there still could be multiple matches. That's where it can use the longest match to match up the best route. And then finally, we ended up talking about what if there was no matches, then we would have to just drop that packet. If there was no default route and there was no other matches, then we would drop it.